All right, so solving exponentials, it is the most useful when you're trying to figure out when your bank account is going to reach a certain amount. So if you're trying to save up for like a certain vacation or a certain car, a certain whatever, this is when you would be useful to you guys. So let's say you want to invest $5,000 into a bank. That bank is going to pay you 6.25% interest, which, dang, that's a great interest rate, compounded monthly. And so to the nearest year, how long should your money be in the bank so that it's going to reach 6,500? So if it's compounded, we're going to go back to that compounded interest formula from like lesson 5.2. So our formula is A equals, and so this is our amount that we want. So that is actually what's going to go on the left side. So what your goal is. And then your formula is your principal, which would be 5,000. That's what you're investing. We've got 1 plus, because it's an exponential growth problem. You got a fraction. Your rate goes on top. But again, this 6.25, you need to move the decimal once, twice. So this will be 0.0625. On the bottom is how many times it's compounded. We know monthly means 12, so 12 would go at the bottom. And then again, 12 repeats. Your N is both on the top and the bottom. And then times our time. So I don't know the time. I have no idea how many years it's going to take for me to earn $1,500. So we're just going to solve this equation, and that'll tell me the answer. So there's two you could divide by 5,000 first. I like to simplify the parentheses first. So step 1, in my opinion, is to type this in the calculator, but leave the exponent out there. So I would type 1 plus, get a fraction, so alpha y equals enter, 0.0625 over 12. Okay? So here is our very long decimal that probably goes on for forever. So we're going to leave this in the calculator, but for writing purposes, I'm going to round it. So I'm going to do 1.005. So again, ... like it went longer. And then you have 12t, and then we have 5,000 equals 6,500. So just know this number is not exact. All right, so we need to get rid of 5,000 first. It's being multiplied, so I'm going to divide by 5,000. All right. So now, you could actually get a number, or we could just cancel out these zeros and leave it 65 over 50. But what is 65 divided by 50? 1.3. Cool. So I'll go ahead and simplify that to 1.3. Then we had my 1.005 ... number with my 12t. So now, this time is in the exponent spot. I want to get it out of the exponent spot, which means turning it into a logarithm. Now, you guys are not used to seeing the exponent on this side, so if I flip the whole problem around, it may help you out. So if you don't need to do this step, you can totally skip it. But if I turn this into a log, it'd be log base this of this. So log base 1.005 ... of 1.3 equals your exponent. So again, if you can go from this step to this step, go you. I like to put the base on the left so I can do my little L. Now, so I've got log base, yada, 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 1.3 equals 12t. I'm almost done. I want to get t by itself. So we're just going to divide by 12 on both sides. T is by itself, and that's our answer. I just have to type all that loveliness into the calculator. Now, if you do not use this exact 1.005 ... number, your answer is slightly incorrect, and we want to know exactly if we're talking about money. So, first thing, you need a log base button. So I'm going to head to the calculator, go to math, go to log base. Now, this 1.0, I want this number to appear right here. So if you go up to that number where it's highlighted and hit enter, it will copy it for you. Then the next number is 1.3. And then all of that is being divided by a 12. Okay? So that is our answer. So it's going to roughly take about 4.2 years to earn that money. So 4.2 years. Okay? Let me kind of show you the errors you could get. For example, if I delete all these numbers and I had just used that number, see how off it is? So because logs are like exponentials, and exponentials grow really rapidly, so do logs. And so if you're off by like 0.0002, it definitely changes the amount of months. So especially when you're doing homework, when you're doing tests, make sure you're using this entire decimal. Okay? All right, so that's how it's useful to you guys. You put your goal in mind, you put what you invest in the bank, you put your interest rate, how many times it compounds, usually 12, and then that's how you can figure out how much money you would have. So let's do a fun problem. So, Miss Natora, let's say I have $60,000 in the bank. My bank is going to pay me 3.3% interest rate compounded monthly. When will I become a millionaire? Right? So, see if you can try this problem. Very similar to what we just did. And I shall show you the answer. So press pause. Try it on your own. So step 1 is to write a lovely equation. So a millionaire is that many dollars. Bada boom, 3.3% would be 0.033%. Or not percent, as decimal. Again, I like to type in this loveliness into the calculator. Now, fun, it wasn't a crazy decimal. So you could just write that entire thing on your paper, and it wouldn't be too bad. Then I divided by 60,000. Again, a shortcut, you can just cancel out these zeros. So I left it 100 over 6. Because that's a crazy decimal. So I would just leave this on the left side, 100 over 6. Because we want to be as exact as possible when doing logarithms and exponentials. So here's what I have after simplifying. Again, we're used to seeing the base on the left side. So now, if it's on the left side, I can do my fun little L thing. So it'd be log base this of this equals 12t. So log base that of that equals 12t. Again, divide by 12. And we just have to type in this into the calculator. So if you had left this as a decimal, which is totally fine, I will show you. So I would go to math, go to log base, and we can start copying numbers. So this was my base, hit enter. This was my of, oops. So that would go, oops. Dang. You have to go in the parentheses first and then go up. Gotcha. So log base that of that, and then divide it by 12. Okay, so in 85 years, Miss Natora will probably not be alive anymore. So yay, I'll be a millionaire when I'm dead. Wah wah. So that's how this stuff is useful to you guys. So thanks for watching Solving Exponentials, and now you can head to practice.